Well, hi. I'm glad you could join me. Today we're talking about congruent and right triangles. So we're going to be talking about a new shortcut that we can use for proofs, and that's going to be the hypotenuse leg theorem. So again, it's another shortcut that can only be used in right triangles. First, you have to remember what is the hypotenuse. Well, every right triangle has the hypotenuse, and the hypotenuse is always the longest length, and it's always straight across from your 90-degree angle. So it's the longest side and straight across from your 90 degrees. The other two sides are going to be called legs, just like in an isosceles triangle. So my theorem is this. If I have two right triangles, I first have to know that they're right triangles, and I know that my hypotenuse are both congruent, and I have a separate leg that is congruent. Then I can prove that two triangles are congruent, and my shortcut would be hypotenuse leg. You can only use this in right triangles, only right triangles. So in order to use hypotenuse leg, there's three conditions that have to be met. First, you have to have right triangles. If you don't have right triangles, you can't use hypotenuse leg. Second, you have to make sure that the hypotenuses are both congruent. If they're not congruent, then you can't use it. And you just need one pair of congruent legs. So my friend Raymond, he built a triangular supports for a picnic table with the dimensions shown. So are the supports congruent? Well, if I think about my conditions, the first thing I have to look for is, are there two right angles? So yes, both of these are right triangles. Then I want to check to make sure that my hypotenuse, so straight across from my 90 degrees, they're congruent, and they are. They're both 26. And then I want to make sure that I have another side or leg that is congruent, and I have 24 and 24. So yes, they would be congruent by hypotenuse leg. So here's a proof. Whenever you have perpendicular, you're probably going to be using hypotenuse leg. So I have CD is congruent to EA, and AD is the perpendicular bisector of CE. Perpendicular bisector gives me two things. First, this perpendicular part. So if AD is the perpendicular bisector of CE, looking at this length, that means it's creating two 90-degree angles. So I'm going to write as my second step, angle ABE is going to be congruent to angle CBD. And the reason I can say that is because of perpendicular bisector. Because two perpendicular lines create 90-degree angles. All 90-degree angles are going to be congruent. And then the other part I have in this given statement is bisector. So bisector means that this line right here, AD, bisected this line. So basically it cut CE in half. So if it cut it in half, then I know that I have two congruent parts. So I can say CB is going to be congruent to BE. And that could be definition of perpendicular bisector. So now if I look at my picture and what I've proven, again, if this is confusing to you, you should always draw one of your triangles over to the side. You've proven that you have a 90-degree angle. You've proven that you have that side congruent and this side congruent. So now when I'm looking at this, I can have my next statement as triangle AEB is going to be congruent to triangle DCB. And the reason I can say that is when I'm looking at this, I have a 90-degree angle, and I have my hypotenuse is congruent, and I have another leg that's congruent, so it would be hypotenuse leg. So that's all for today. I'm glad you came to play. Hope your day goes wonderfully, and make sure you fill out the Google Docs. Have a great night.